and what we are doing today, all right? So what we're doing today, the only difference is we are using inequalities. So what does that mean? It means that your language in your question is just going to be a little different. So for example, like yesterday, it was all, they went to the store and spent this exact amount of money. So they spent $50 on cupcakes and cookies or something. So you notice that it equal. But when we use inequalities, it uses language like at most or at least. And that is just signifying that there are more than one solution, right? Like when I say this in class, a lot of times when we talk about inequalities, I say to you, is 7 the only number in the whole entire world that is bigger than 5? And you say, no, Miss Lyons, there's a whole bunch of them. And that's exactly what inequalities are, okay? It's a solution set. So we're just going to go over this verbally instead of writing it down, but I have a system of linear inequalities, a system because I see 2 lines, and that means I don't have just one, I have a system, okay? And the shading, so that is what is mostly different about graphing inequalities. It's the shade, because just like we said it's a solution set, so it like shows a whole bunch of numbers. And if I just cover this really quickly, this whole gray area is the solution to this line, okay? So this solid line, if you shade down here, this is the solution set to what satisfies the inequality of this line. If I cover this gray one up, this shade over here is just lines. That's the solution set to this line. So all of these 2 points, these x's and y's, will make this inequality true. This shaded area will make this inequality true. And then this big area labeled with an A, that is your solution set that makes both of these inequalities true. So this area for A that has the double shade, that's your solution set to the whole entire system, not just one singular line, okay? So that was that was all of those. And the only thing we have to talk about really quickly is 2, -3, a solution to this system. Okay, first I'm gonna find it. So here's 1, here's 2, here's -1, -2, -3. Okay, so this is the point it's talking to me about. This, we'll catch you here, okay? This was on the Regents not even that long ago. They put it smack on a dotted line and they said, is this the solution? Wrong, it is not a solution, because remember when we first learned these, we said, if the line is missing portions of the line itself, like these little dashes, it means it's missing some portions of a solution set. So not everything is true. What? You're blinking out. Okay.
I can hear you.
I can barely hear you. It sounds like your internet is wonky. Can everybody else hear me?
I can.
You can? Okay.
Yeah, I can.
Okay, thank you.
Yeah.
Good. Okay, so he must be wonky for you, Brandon, not sure. Okay, we're gonna keep trucking now. So, not a solution on the dotted line. You don't wanna be dotted. All right, so what we're gonna do today, I'm really only gonna do one exercise with you. I'm gonna do 2. I'm not gonna do exercise 2, only because I tried to I don't like the way that Delta Math actually asks these questions. So I couldn't find any good ones, so I'm not going to waste our time with that one, okay? But I am going to do exercise 1, because exercise 1 is what you're going to see. This is actually a Regents question. I think it's from like 2015. So this one was on the Regents, so this is a good one to go over. The first thing I have to do for you though is I was terrible in picking this graph. This graph should only be the first quadrant, so I'm going to change this so it's like this instead. Okay, so pretend that these little axes aren't there, and these are our regular axes. Alrighty. So we're going over the same concepts that we did with systems. I have beautiful Edith. She's babysitting for X hours a week after school at a job that pays $4 an hour. If you're babysitting, please charge more than $4 an hour. Life tip. She has now accepted a job that pays $8 an hour as a library assistant, and she's working Y hours a week. She will work both jobs, okay? She is able to work no more than 15 hours a week due to school commitments, and Edith wants to earn at least $80 a week working a combination of both jobs. So part A says, write a system of inequalities that can be used to represent the situation and graph the inequalities on a set of axes. Okay, so what is nice is that when you do see these on a Regents, you're not going to have to guess if it's a system of equations or system of inequalities. It will usually tell you. So this one tells me inequalities, so that means I better have inequality signs, okay? But just like a normal system, the first thing I ask myself is, what is she doing, right? So she's babysitting and she's working as a library assistant. So she's babysitting for X hours and working as a library assistant for Y hours, okay? And notice how I'm talking hours and I just had nothing about money. And she can work no more than 15 hours a week, okay? So between these two jobs, it has to be less than or equal to 15 hours because she can't work more than that. You want to work less and make more all the time. Okay, so now all we're going to do is talk about the dough that goes with this. So how much is she making? So Edith, she works X babysitting, $4. Okay, so that means I have 4X, and as a library assistant, 8Y, okay? And just logically, of course, she wants to earn more than $80 a week. So she wants to earn at least 80. But if they said, you want to know what, Edith, I'll give you $150, she's not going to say no. So she wants at least, for whatever she's working, she wants more than $80. Okay, write a system. Done. Graph these inequalities. Okay, so this is just like a system, okay? Just like a linear system. If I want to graph it, that means I have to graph both of these lines on this axis. So the first line I'm going to graph is this one. And the second line I'm going to graph is this one. All right. And if I have to graph, that means I have to solve for y. So I'm going to cover y because I don't want to see it in front of the x. I don't see a minus, so that must mean there's a plus. If I want to move it to the opposite side of the equal sign, I have to subtract it. Okay. Perfect. And then down comes y. So y is less than or equal to 15 minus x. Okay. So before I get confused, I'm going to put this right on my graph. All right. So I'm going to cover my slope, and it tells me I have to start when y is 15. So that means I'm going to go over to my graph, my y-axis, and put a point at y is 15. So here's 0, 1, 2, 3, 4, 5, 15. Okay, that's done. Now I have to think about my slope. I don't see anything in front of there. Doesn't mean there's a 0. If there was a 0, it wouldn't be there. So there's a 1. So it's 1 over 1. If there's a minus sign, tack it on to the top. So this one says down 1 to the right 1, down 1, right 1, down 1, right 1. Lots of dots. Okay. Now I have to decide if it's dotted or solid, and I have to shade. Here's the tip. Solid line underneath here. Solid line on your graph. Solid, 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 solid. Oh, I kind of missed, but that's okay. I even have a ruler. How terrible. Okay, so now I have to shade. This says y is less than this line, okay? Less than means lower. So I'm going to just shade everything that's lower than this line. We're all downwards. Okay, Next one, same idea. I'm going to solve for y, cover it. Right in front of my 4x, I don't see a minus sign, so that must mean that there's a plus sign. To move it, I'm going to subtract it. So minus 4x, minus 4x. Alrighty, cancels, comes down to play. And I get 80 minus 4x. And then I get to divide by 8. All right, and then I'm just left with y is greater than or equal to 80 divided by 8 is 10, and 4 divided by 8 is 1/2 x. Okay, dokie, same deal. So now I can graph it. I cover my slope, and it tells me to start at y is 10. So I'm going to start at y equals 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, my slope. I'm going to tack the minus sign onto the top, so I'm going to go minus 1 to the right 2, so minus 1 to the right 2. Okay. Right, once I get past that, I'm going to turn my paper a little bit so I get a nicer line here, because I really screwed up that last one. All right, beautiful. And this says y is greater than my line. So greater than means upward towards the sky. So I'm all above this line. Wow, this is so lovely. Okay. B. So that's all of A. Graph them, solve them, good to go. Determine and state one combination of hours that will allow Edith to earn at least $80 per week while working no more than 15 hours. So that is exactly what our system is, okay? So determine and state basically is asking you for a solution to the system. Solution is where I see hashtag solution, okay? In the middle, where they're both crossing each other. I'm gonna choose, there's lots of different answers, so it doesn't really matter, but I'm gonna choose this one right here because it is snug in the middle, okay? Please do not pick anything close to those lines. I'm gonna scream if you do, okay? So right in the middle, all right? And I'm just gonna write that ordered pair down right over here. So it looks like my x is 2, and my y is 1, 2, 3, 11. Okay, I just wrote it down, so now I can actually tell you the amount of hours. This does not mean anything, okay? I have to determine how many hours babysitting and how many hours the library assistant she works. So my x-axis, 2 hours, okay? On my x-axis, I'm talking about Edith babysitting. So 2 hours babysitting. And 11 hours, okay, on my y-axis, which is library assistant. If we wanted to be official, we would use complete sentences, but this will do, my friend.